Alright, so I just wanted to add another example about pullbacks here. So let's consider this function. F of uv is u plus v, u comma u minus v. You can pretty easily see that this is just a mapping. Well, I guess you could look at it as a patch on a plane, but I'll look at it as a mapping between the surface. I mean, it's potato, whatever. uv maps f over here to this, plane through the origin, apparently. Right. Not drawn to scale or anything like that. Just a heuristic picture I like to draw. And so, like, what's the inverse of this map? Let's see here. Figure that out. If I set this equal to xyz and I solve for it, that gives me what? That gives me x equals to u plus v, y equals to u. Hey, that's nice. Z is equal to u minus v. So obviously we have y is equal to u. And we also have that x minus z is equal to 2v. So that gives me v is equal to 1/2 of x minus z. And so the inverse mapping of xyz is simply equal to, let's see here, y comma 1/2 of x minus z. All right. And now we can do things like we could, let's see here. Let's see here, what do we want to do? We got these toys to play with. What do we want to do here? Let's look at a one form, which is perhaps interesting. Alpha equals to, let's say, u tilde dv tilde up here. Let's see here. So let's see. We would expect that d alpha is what? Well, d alpha should be du tilde wedge dv tilde. Not that we've justified that, but it should be true. And let's see here. What else? If we pull back alpha under f, we could talk about the pullback of alpha. What would we expect the pullback of alpha to be? Well, let's see. Pullback of alpha is what? Pullback of alpha acting on, for example, u1 would be alpha acting on the push forward of u1, right? Which would be alpha of xu, which would be, okay, well, there's something. And the pullback of alpha acting on u2 likewise will be alpha of xv. All right, and so if you look at that, then the pullback of alpha is going to be alpha of xu du plus alpha of xv dv by our usual basis results. But of course we can actually calculate alpha of xu and alpha of xv up here, because, like, for example, alpha of xu would be equal to u tilde dv tilde acting on xu, which would be u tilde dv tilde acting on xu, which is 0. On the other hand, alpha of xv would be u tilde dv tilde acting on xv, which would just work back to u tilde times 1, right? So now let's see. So that gives me u tilde, although I think, where am I? Oh yeah, so I just figured out this is 0 and this is u tilde, but it's not u tilde anymore. It should really just give me back u. See, we'd see that from chasing down the point dependence, which I'm being a little sloppy about at the moment. So u with the fine print. So we get u dv, right? Now, admittedly, I haven't explained exactly why the u tilde becomes a u, but that has to do with the pullback. Anyway, if you can forgive me for that small omission of detail, then you can see that d of f pullback alpha is d of u dv, which of course is du wedge dv. And also, d alpha was what? It was, well, it was du tilde dv tilde. So what's the pullback? What's the pullback of d alpha? Well, it's the pullback of du tilde wedge dv tilde, right? But that is the pullback of du tilde wedge the pullback of dv tilde, right? And I don't know, maybe you recognize this or not, but really I could have, maybe it would have been, probably it would have been better if I had called f capital X, because after all, we're really just dealing with the patch on a plane. And as you know, the pullback of du tilde just gives me du, and the pullback of dv tilde gives me dv, as we proved earlier in this lecture. And there you have it. The differentiation before or after the pullback ends up being the same result. I mean, it doesn't matter whether you pull back first and then differentiate or vice versa. It's also fun to look at this in terms of like the global Cartesian coordinate frame. And there's another example of perhaps the unreasonable success of the differential notation. So like a different way to look at this calculation would be alpha is equal to, so I defined it as u tilde wedge dv tilde, right? But if I convert that to xyz, let's see here, u tilde was y, and v was 1/2, so I could do y over 2 dx minus dz, right? And then so like that tells me d alpha, of course, is 1/2 dy wedge dx minus 1/2 dy wedge dz, right? On the one hand, and so let's see here. On the flip side of things, the pullback of alpha, you could do, what do I got here? Where's my alpha? Oh, I lost my place. Oh, I'm sorry. So basically, to pull back alpha, what I do is I take this and I convert it to u and v expressions. That's at the heart of what the pullback is. So y becomes u over 2, and dx becomes du plus dv, and dz becomes du minus dv, yeah, which is equal to what? That's equal to, of course, the du's cancel, and I get 2 dv, 2 times a half, so I get u dv, which of course is what we found before using a different way of thinking. But you see that the pullback you can get also from just plugging in the formulas into the variables and making the appropriate substitution. So when I talk about this in advanced calculus, I try to sell the pullback more as a method of substitution, because that is at its heart what it is really about. But it's not quite that all the time either, because you can do the pullback between spaces of different dimension, and certainly there it's not just substitution, it's something different. Let's see here. So, to pull back d alpha, let's see, pull back d alpha in my current heuristic, admittedly heuristic, way of calculating, the pullback of d alpha would then be, so I take this 1/2, and I take this 1/2 dy wedge dx minus 1/2, come on, marker. I take this expression right here, and I substitute you know, u and v expressions for the x and y and z expressions for x, y, z expressions, and just formally differentiate. So, like y is u, so I get 1/2 du wedge. Well, what's dx? Well, dx is x is equal to what? X is equal to u plus v, so that's du plus dv, and then minus 1/2 dy. Well, y was u, so that's du wedge with, let's see here, what's dz was du minus dv, and let's see here, so du wedge du is 0, du wedge du is 0, but I get du dv, and I get d minus du dv, but minus minus gives me plus, so I get du wedge dv, which of course is also equal to d of u dv again. Okay, so anyway, whichever way you skin a cat, we still get the desired outcome. Right? Oh, I'm sorry for the cat lovers out there. What have I said? Oh no. All right. We'll move on then.